So in this video, let us look at the Euler form of a complex number. So this form is very closely related to the polar form of the complex number. So Euler, the mathematician Leonhard Euler, has proved that cos theta plus I sin theta can be expressed as e power I theta, and cos theta minus I sin theta can be expressed as e power minus theta, e power minus I theta. So Euler has proved that this can be written as e power I theta and this can be written as e power minus I theta. So I am not giving the proofs right now, but you can derive this once you complete the calculus course, which involves the basic differentiation. So once you understand the Taylor's expansion of a function, you can understand how these results are derived. So once you know that cos theta plus I sin theta is equal to e power I theta, cos theta minus I sin theta is equal to e power minus I theta. So if you have a polar form r times cos theta plus I sin theta, so this can be simply written as r times e power I theta. So this form is called the Euler form of the complex number. And r times cos theta minus I sin theta can be written as r times e power minus I theta. So these are the two Euler forms that you need to understand. For example, so if you have 2 times cis pi by 4, this is the polar form. This can be written as 2 times e power I pi by 4. Root 3 cis minus 2 pi by 3, if you have this complex number, the corresponding Euler form is root 3 times e power minus I 2 pi by 3. So it's a very straightforward conversion. So cis theta is written as e power I theta. Cis minus theta can be written as e power minus I theta. So these are the conversions from polar form to Euler form. And Euler form will be useful when you're dealing with multiplication of complex numbers, because the multiplication of complex numbers is very easy in Euler form. So if you have a complex number z1 is equal to r1 times e power I theta 1 and z2 is equal to r2 times e power I theta 2, the multiplication and division becomes very easy in Euler form. What is z1 z2? Is nothing but r1 r2 times e power I times theta 1 plus theta 2. Very simple, right? And what is z1 by z2? Is nothing but r1 by r2 into e power I times theta 1 minus theta 2. So the usefulness of Euler form comes when you're dealing with multiplications. So when you're dealing with additions, Euler form is quite cumbersome. When you're dealing with addition, try to use the algebraic form. When you're dealing with multiplication and divisions, try to use the Euler form. So somewhere in between, you can use the polar form of the complex number. Thank you.